this next example, we're going to do exactly the same as what we did before by identifying key points first to create a graph by hand for this quadratic function. So the first point we're going to identify is the y-intercept, and to find y-intercept we let the input be 0 and g of 0 gives us a constant term which is -8, and therefore the y-intercept is 0, -8. And then we want to find the mirror point of y-intercept. And in order to do this, we need to, along the way, find the axis of symmetry, and we can go ahead and use that to find the vertex first. So to find the symmetry or the vertex in this process, we can use a formula we have for x equals -b over 2a to find the x-coordinate of the vertex, or the line equation of axis of symmetry, which gives us -8 over 2a, which would be 2 times 6. There's some cancellation we can do over here. Factor of 2, this becomes a 4. Factor of 2 again, this becomes 2, this becomes 3. So we get -2/3 as the axis of symmetry. And therefore, to find the vertex, we want to go ahead and use the input being -2/3. So g of -2/3 is what we're going for. And this gives us 6 times -2/3 squared plus 8 times -2/3 minus 8. This is going to be, again, a little bit messy to calculate, but we'll have 6 times 4/9 plus, or really minus, 16 over 3 minus 8. So with some cancellation, a factor of 3, so we get 2 over here, 3 over here. So this works out nicely. We get 8/3 minus 16/3 minus 8. So altogether, we can rewrite 8 to have a denominator of 3 as well. Initially, it's 8 over 1, so multiply 3 on both sides. That gives me 24 over 3. So 8 minus 16 minus 24 all over 3 gives us -8 minus 24, which is -32 all over 3 as a result. And that's going to be the y-coordinate of the vertex. So we get -2/3 and -32/3 over here for the vertex. Now for the mirror point of the y-intercept, we can use the fact that the y-intercept has x-coordinate equal to 0, which is equidistance away from the axis of symmetry compared to its mirror point. So its mirror point should be 2 times the x-coordinate of the vertex. So we get -4/3. And then it's the same height, so -8 is still going to be the y-coordinate. And that's going to be the mirror point we get. And next, we want to think about how we can find the x-intercept over here. And to find the x-intercept, we want to go through the factoring process in order for us to identify these values. So here, g of x needs to be factored, and anytime we factor, we first want to think about what's the GCF, whether there is any GCF across the board, so we can go through that factorization first. So using this, we can say that here g of x can be factored out. This entire expression can have a factor of +2 out. So with this in mind, if we do so, we would have 2 times 3x squared plus 4x minus 4. And by doing this step, it's going to make our factoring process easier. Later on, our numbers are going to be much smaller. I'm going to have to move up a little bit so we have a bit more room to work with. And in order to find the intercept, I really just need to focus on the part inside the parentheses. And here that tells me I need a product that's equal to a times c, or 3 times -4, my new a and new c, which is -12. And I need a sum that's going to be the linear coefficient, which is +4. And if you test out all the pairs for negative 12, you will find the two numbers that would work is positive 6 and negative 2. They add up to positive 4. And to do that, we can rewrite 3x squared plus 4x minus 4 is equal to 3x squared plus 6x minus 2x. Then minus 4. Again, first two terms are together, last two terms are together, connected by addition. In the first group, we have 3x in common to be factored out, and that leaves us x plus 2. And in the second parentheses, because the leading term is negative, we can factor out negative 2 altogether, leaving us x plus 2 again. And with x plus 2 in common to be factored out from each group, I'm left with 3x minus 2. And to use a zero product principle, that tells me x plus 2 equals 0, or 3x minus 2 equals 0. So x is equal to negative 2, or 3x is equal to 2, hence x equals 2/3. So we really have the 2 points being negative 2, 0, and 2/3, 0 being the x-intercept of our function. And lastly, we want to find two additional points that are symmetrical to each other across the axis of symmetry. That again, we have a little bit more flexibility. Just looking through the values I have for x coordinates, I can again pick x equals 1 just for simplicity reason, and I'm going to go ahead and do so. If x equals 1, I'm looking for g of 1 equal to 6 plus 8 minus 8, which is equal to 6. And to find its mirror point, we want to incorporate the axis of symmetry being negative 2/3. And if we had negative 2/3 being axis of symmetry, that 0.16 has to be to its right. And in order for it to be equal distance, we first want to find the distance between the two. So we're just looking for the difference between the x values. So 1 minus negative 2/3 would be 5/3. And equal distance to the other side would mean I want to go another 5/3 to the left of negative 32. Altogether, negative 2/3 minus 5/3 is going to be negative 7/3. Therefore, this point, the mirror point, is going to be negative 7/3, 6 over here. So these are the two additional points I can use in order to create the graph. Now looking at all the values, you can see on the y direction I have some pretty large values like negative 32 over 3 over here, and including negative 8 is pretty negative. But on the x direction, I don't have any number that's super big. It goes to as negative 7/3. So I have a bit more flexibility to work with on the x direction, which is going to be nice because I have a lot of denominator of 3. And with that, if denominator 3 is showing up a lot on the x direction, I'm going to use every 3 boxes as 1 unit. So I have 1, 2, 3 here, and negative 1, negative 2, negative 3 here, if I counted the boxes right. On the y direction, I don't have as much room because I have to fit larger numbers. So I'm just going to go with each box being 1 over here. So that would be negative 2, 4, negative 6, 8, negative 10 over here. And then for the positive direction, I'm going to do the same. Like this. And now if I want to plot the points, the first point is 0, negative 8. I'm going to go ahead and put that in. Then negative 4/3, negative 8 would be just 4 units to the left, 4 boxes to the left of the y-axis, negative 8, which is a mirror point. And then we have the vertex, which is negative 2/3, negative 32 over 3. Negative 32 over 3, if you calculate it, it's a little below negative 10. So it's closer to negative 11 than it is negative 10. And then we want to put in the x-intercepts, negative 2, 0, and 2/3, 0. Lastly, we have negative 7/3, 6. Again, it's nice to have the units go in every 3 boxes, so negative 7/3 exactly 7 boxes to the left of the origin, and the y-coordinate is positive 6, so it's right here. Lastly, 1/6 is going to be right here. And again, we have 7 points. We can connect all the points with a smooth curve as much as possible. And that's going to give us the graph of our g of x over here. Take a minute to make sure that every point makes sense in this process. This takes a decent amount of work to kind of work out the values, and any type of scaling that's thoughtful would make the graphing process a little easier as well.